Hello everyone. I'm Masaki Mitsugi from METI, Ministry of Economy, Trade and Industry, Japan. Thank you very much for giving me this opportunity. Recognizing the current situation of increasingly sophisticated and diverse cyber attacks, METI aims to suppress and defend against cyber attacks on industries in Japan, minimizing their impact on business activities. We have been planning and implementing a variety of policies to achieve this mission. Also, we have been seeking to connect various initiatives to strengthen the competitiveness of our country's industries. Today, I'd like to introduce our initiatives regarding SBOM. In recent years, the importance of software in industries has been growing as the cyberization of industrial activities is progressing. Specifically, the introduction of software has been advancing even to control industrial machinery, automobiles, and other devices. In addition, concerning IoT equipment and services and 5G technology, companies are likely to use software embed a variety of functions in hardware systems already established by using general-purpose equipment. It is expected that such use of software will create various added value. As in these examples, a growing number of companies has been making use of software, including open source software. On the other hand, companies are facing growing security threats to their software, such as the serious impact of those vulnerabilities to company management. To strengthen their own security, it is important for companies to manage it. However, as software supply chains were becoming more complex and the utilization of OSS is becoming popular, companies are facing a difficulty in ascertaining the details of components of software, even though it is applied to their own products. Regarding the management of the vulnerability as above, SBOM, which is also called a list of software components, attracts companies' attention as one of the methods to solve challenges that both software development organizations and user organizations face. While the use of SBOM is expected to have positive effects, there are remaining issues, such as the high cost of implementation and strong resistance from players to create SBOM and disclose the data. In addition, you may want to use automated tools to manage SBOM, but automation may be difficult because the software IDs and SBOM formats are not standardized. Therefore, we have conducted a proof of concept, POC, to confirm how SBOM can be used efficiently and cost-effectively. This slide is an overview of POC we conducted in 2022. Through this POC, we compared and evaluated the cost of effectiveness in each sector and organized the realistic scope of application and issues to be addressed. We selected 3 industries which were expected to gain benefits from using SBOM: medical equipment, automobiles, and software. We also conducted an evaluation by considering the software supply chain. The table below shows the POC implementators, related companies, related legal systems, and target products in the 3 fields. Through this POC, the benefits and effects of SBOM were confirmed, especially the benefits for software vulnerability management and license management, which may result in the benefit of increased development productivity. Based on the POC we conducted, we released guidance on introduction of SBOM for software management version 1 in July 2023. The guide provides basic information on SBOM, including advantages of introducing SBOM to companies and misunderstandings and facts about SBOM. And it also offers phase-by-phase key points that companies should recognize and conduct in introducing SBOM, namely environment and system development phase, SBOM production and sharing phase, and SBOM use and management phase. This guide is primarily aimed at software suppliers involved in packaged software and embedded software. Of course, user companies that procure and utilize software can also make use of this guide. It serves as a vulnerable resource for organizations facing challenges in vulnerability management in software, as well as for those that recognize the term SBOM and the necessity of its implementation, but are unclear about the specific benefits and methods of adoption. This slide presents the necessary procedures for the implementation of SBOM. There are 3 phases. The first phase is to develop the environment and system phase. In this phase, we include 4 steps: clarification, the scope of the SBOM application, SBOM tools selection, SBOM tools installation, and learning about SBOM tools. And we indicate the action to be taken and points developers should be aware of in each step. The second phase is to produce and share the SBOM. In this phase, firstly, developers analyze the component and they create SBOM. The SBOM is to be shared as needed. The third phase is SBOM operation and management phase. In this phase, developers implement measures such as vulnerability management and license management based on the output of the SBOM tool. Furthermore, even after creating an SBOM, developers needed to appropriately manage the information contained in the SBOM and the SBOM itself. Since this formulation, we continue to hold discussions on the methods according to which all companies, including small and medium-sized enterprises, can further efficiently make use of SBOM. Following this, we formulated a revised version of the guide in August of this year. There are 3 specific additional items in the guidance version 2. First, specific procedures and approaches to helping companies to effectively utilize SBOM in a series of processes for managing software vulnerability. The security benefits of utilizing SBOM is the reduction of the potential for exploitation of vulnerabilities through effective vulnerability management. Therefore, the processes related to vulnerability management become particularly important. By compiling information focused on these processes, we hope to enhance the effectiveness of SBOM. Second, framework for helping companies to consider the scope in which they can appropriately introduce SBOM by taking into consideration the effects and costs of the introduction. When creating and utilizing SBOM, it is essential to consider the scope of SBOM. This scope can significantly impact both costs and effectiveness. For example, the range of software components identified by SBOM may vary based on whether it includes components from outsourced development partners or third-party vendors, and whether it targets only the components directly used by those entities or also includes reused components. This can lead to substantial differences in the range of components that can be managed. Additionally, if the scope of the component identification varies, the range of vulnerabilities detected will also differ, leading to significant implications. Therefore, it is effective to aim for reasonable scope of response that aligns with the differing risks in various industrial sectors and system usage environments. A SBOM-compliant model serves as a proposal for this reasonable scope. This section also provides reference examples of a SBOM-compliant model in the fields of medical devices, automotives, and software products. And third, certain matters that should be stipulated about SBOM in contract to be concluded between companies and subcontractors. By promoting this guide, we believe that the adoption of SBOM in companies will lead to a reduction in an initial response time to software vulnerabilities and a decrease in management costs. Furthermore, we also expect that it will not only enhance development productivity within companies, but also contribute to improving cybersecurity capabilities across the industry. We have published the English version of the initial guide. The English version of the revised guide is also scheduled to be announced soon. So we would be grateful if you could look. We will continue to engage in information exchange and advanced discussions aimed at the effective utilization and dissemination of SBOM. Thank you for listening. It was my pleasure to be here. Thank you.